Okay, so in the previous class, we were discussing about the halting problem. In the case of the halting problem, whether the Turing machine accept the input string, so it halts on the final state. If it is not accepting the input string, it halt somewhere in between the intermediate state. So this problem of the Turing machine, we called it as the halting machine Turing machine problem. And inverse of it is exactly, see, it is if it is halt on the final state, okay, that means it is going to accept the string. So it is the inverted one. So here we are making the accepted one is non-accepting one. So by introducing two more states, so it enters in the infinite loop. Okay, so once the machine enters in the infinite loop, it never terminates, it never halt. Okay, it never halt. Okay, infinite means so there is a no end, so it never halt. If it is rejected, so we are making it to halt. We are making it to halt. Okay, but it halts in the intermediate state. Hence, so we can call it as the inverted Turing machine, inverted halting machine, or you can call it as a inverted Turing machines. So language decidability. So any string of the language is having its own Turing machine. Such a language, we called it as a language decidable. For example, you can see here. So Turing machine is observing the decidable language that indicate that. So all the strings of the language having its own Turing machine, and it is acceptable. Acceptable means so after reading the last symbol of the strings of the language, so it is going to terminate or halt at the final state. So such a language, we call it as a language decidability. So, in the case of the non-language decidability, for example, undecidable languages, you can call. So, the pictorial representation goes like this. See, undecidable languages. So, decidable language has a Turing machine. It is lying behind the decidable languages. So, Turing machine is there only for the decidable language. So, the remaining part, so Turing machine is not there. So, only Turing machine is available for only this part. It can observe only the languages which is decidable, okay, which is accepted by the Turing machines. So it is undecidable languages are lying behind this Turing machine. So such a language, we called it as the undecidable languages. So these are the languages which do not have the Turing machine, called as a non-Turing acceptable languages. Non-Turing means so they don't have the Turing machine to accept the languages. Such a languages, we called it as a the non or undecidable languages. So it is called as a undecidable languages. So questions are asked. Please, you have the question paper. Please just go through the question paper. So glance it, and I am sharing the question bank also. Just glance the question paper. Please tell others to attend the class because it is very important. Okay, so you can read yourselves, but understanding some of the concept is very difficult. That's what, see, especially some of the student, they are very weak in the first and second module. So please, there also they have not attended the classes. So if they miss today classes also, they may come in the big problem. Okay, please send the message. Varshit and Devrat is there. Okay, please take care about the student whichever I listed in the list. So please tell them to attend this class. Okay, only half an hour to 45 minutes I'm going to engage. So after that, I'm going to conclude. Okay, so this is decidable and undecidable languages. So next we have the jump Turing machine. So what is this jump Turing machine? Turing machine, we know, so it is defined as q into the tape symbol is equal to q into tape symbol left shift as well as right shift. So along with this transition function, we have the n also. So n indicate that. So shift. See, generally what happen Turing machine. For example, you can take the string a n bn, a n bn. Generally, how do you describe if n is greater than or equal to 1? You describe the string as a b b like this, or a b b like this. Okay, so generally Turing machine convert all these input string into the tape symbol. Maybe whenever it comes across the A is replaced by X, and whenever it comes across the B, it's moving toward the left side. So in the state Q1, so this is while reading the state symbol A, it is in the state Q0. So A is converted into X, and the state is also going to changes to the Q1, and q1 is there, it is moving toward the right side in search of the equivalent symbol for this. Equivalent symbol for the a is b. Whenever the state q1 or machine is in the q1, it comes across the b is replaced by the symbol called as a y, and immediately turn toward the left side in search of the last symbol on the left side. Last symbol on the left side is the x. Whenever it comes across the x, again it turn right, and this symbol is converted into what you can call it as a x. So this is how it converts all a's into xxx and all b's into yyyy step by step. So not one time in a one stretch. So do it step by step. First you convert first a into x, then first b into y, then come back second a into x and second b into y, like that. You can do it step by step. You can do it step by step. Okay, so my system got stuck. Okay, so here what happens, it converts. See, for example, a, okay, b. So it is reading symbol by symbol. It takes first, it reads this, then it reads this has been converted to x. Whenever it comes across a, it reads a, but it is not interested in the a. It is interested in the this b. Hence, it don't cares. It moves toward the right side in search of the equivalent symbol. It reads the a, so it is not bother about the a, but because it is not a equivalent symbol for this a, hence it is continuously moved toward the right side. So every time it is going to read the symbol by symbol. Whereas in the case of the jump Turing machine, what happens? The n is given. For example, you want to jump where n is given as a 2. So in that case, it jumps two symbols. Instead of reading one by one, if 2 is there, it is going to read the next symbol. First symbol is read by this. Second symbol, machine is going to read the this symbol. It is jumping two symbols. So for example, n is equal to, if you are giving it as a 3, so after reading this, the next symbol read by the machine is, it is a b only. If you are specifying it as a 4, so it is going to jump. After reading the first symbol, it is going to jump to the this symbol. So such a jumping Turing machines, we called it as a the jump Turing machine. Only the difference between standard Turing machine and the jump Turing machine is, so in the Turing machine, standard Turing machine, the transition function is defined as only, this is the definition for the transition function in the case of the standard Turing machine. Whereas in the case of the jump, along with this definition of the this transition function, we have the n also. N can be specified by the user. You want to jump, you want to skip two symbols, specify it as a 3. You want to skip three symbols, four symbols, you can specify it as a 4. So such a Turing machine, we can call it as a the jump Turing machine. Turing machine with semi-infinite tape. So what do you mean by semi-infinite tape? The Turing machine generally, for example, this is the input tape, and you can store the what you can call it as a input symbols. For example, blank, blank. Okay, so you can store A, B, B. This is a empty. Empty is replaced by the blank symbol called as a B. So like that B. So this is taking you to the infinite. This end also it is an infinite. This end also infinite. But in the case of the semi-infinite, this end has been terminated. This end has been terminated, and only one end is kept open. I hope you people are making the difference between standard Turing machine and the this what you can call it as a the normal Turing machine with the semi-finite. So in the case of the standard, both side it is infinite symbols you can store. Whereas in the case of the semi Turing machine, the one end is closed. Okay, you cannot store the symbols. This side there is a no tape is there, so it is a terminated on the left hand side. Only opened infinite cells are there on the right hand side. Such a Turing machine we called it as a the semi-infinite. Otherwise, the standard Turing machine is called as a infinite Turing machines. So both the sides, so there is a no ends. Okay, so such a Turing machine we call it as a standard Turing machine, and semi Turing machine the left hand side is closed and only opened on the right hand side, so that you can store the infinite number of the blank symbol, or if the string is very large you can store it till the infinite end. So such a Turing machine, we can call it as a Turing machine with the semi-infinite tape. P class and the NP class. So most of the time, if you have the question paper, please refer the question paper. You can understand. Okay, if you read P class and the NP class, so it is very difficult to understand. Okay, P means a polynomial. P is a polynomial. Generally, what happens? The problem can be solved in the polynomial time. For example, you can take the linear search, binary search, insertion, merge sort. They're all called as a. You can solve it in the polynomial time. Okay. Whereas non-polynomial, you can solve the problem, but not in the finite time. So such a class you can call it as a NP class. NP class means non-deterministic polynomial. For example, you can take the traveling salesman problem, or you can take the graph coloring, or you can take Hamiltonian cycle. So this cannot be solved in the finite number of time, but somewhere you can solve it. They have the solution, but you cannot solve these traveling salesman problem or Hamilton cycle in the finite number of time. So such a classes you can call it as a the non polynomial. So or you can call it as a non-deterministic polynomial class. NP means non-deterministic polynomial class. For example, you can take the world. So you can represent. This is what you can call it as a world. World has a many problems. World has a many problems. This you can call it as a the NP problem, non-deterministic polynomial problem. For example, you have the solution for the problem. So you have the solution for the sum of the problem. So such a problems you can call it as a the polynomial. You can say the polynomial is the subset of the non-polynomial. Excuse me. So polynomial is a solvable. It is a problem which is solvable in the finite time, whereas the non-polynomial, these are all solvable, but you cannot solve it in the finite time. So such a problems we can call it as a NP. Okay, so as I told, world has a many problems. We have the solution for only the sum of the problem. So this is what the problems in the world. The big circle is the problems in the world, whereas the small circle is the, so sum of the problem has a solved. Some of the problems we know the solution for the sum of the problem. For example, when you joined engineering, so before joining, the engineering was, it is like a non-polynomial. The engineering was like a non-polynomial. Okay, we don't know any of the engineering subject. Okay, so first year, if we complete, you complete the first year, you know at least the one fourth of the engineering. One fourth of the engineering. You studied some of the engineering subject. So in the first year, so this part of the engineering, you can call it as the polynomial. Okay. So in the second year, again, you are going to cover some of the other problems. So you are going to cover some part of the non-polynomial. So this is a polynomial and this is the non-polynomial. So in the third year, you are going to study some of the subject. So this is how the non-polynomial is shifted. Polynomial is shifted. Okay, this is a non-polynomial. Bigger circle is a non-polynomial. In the smaller circle, in the third year, you covered this much. While the fourth year, you can the polynomial is shifted. So because you know the higher end subject, so polynomial is shifted at this part. Polynomial is shifted at this part. Okay. So present student, what you are doing? So this polynomial is shifting every year. In the fourth year, the first year, you know these many subject. Okay. In the second year, you know these many subject. In the third year, you covered some of the subject. So while covering the third some subject, you are forgetting the second year subject as well as the first year subject. Okay, so you are not making the polynomial is equal to the non-polynomial. For example, if you are understanding all the subject, see, for example, this is the non-polynomial engineering. So before joining the engineering, this is how the engineering looks, because you don't know any subject of the engineering. So in the first year, you covered some of the subject. In second year, again, you are covering the sum of the subject if you are remembering the first year subject. So like that, in the third year, you are covering some of the subject. In the third year, you are covering some of the subject. So keeping knowing the first year subject as well as the second year subject. So in the fourth year, you are covering the remaining part of the engineering, keeping the first year, second year, and the third year. In such a case, the polynomial becomes equal to the non-polynomial. But if you are making the polynomial is equal to non-polynomial, so this was the engineering was before joining engineering was, it is a undiscovered. Now, with the expansion of the polynomial, so you discovered the engineering. So once you complete the degree, so if you discovered the engineering, that is converting the polynomial equal to the non-polynomial, you can survive in any of the field. In any of the field, if you do like this, so what will happens? So you may be forgetting, only shifting. You are knowing the subject of the different year. Meanwhile, when learning the final year subject, you are forgetting the lower some subject. This should not happen. Okay, this should not happen. You have to expand the polynomial so that you can make equal to the this what you can call it as a non-polynomial. Non-polynomial is a, so before 4 years, the engineering degree was like a non-polynomial. I cannot say it cannot be solved. It can be solved. So, but it is taking the infinite time. So it is taking infinite time. That means almost 356 into 4 days. 366 into 4. So because it is a year, so it is almost taking the finite number of time to discover the engineering. So hence such a problem we can call it as a the non-polynomial. I hope you people are making the difference between the polynomial and the non-polynomial. Simple example I can give. For example, in the case of the polynomial, x plus 3 is equal to 5. Okay, it has a solution. This problem has a solution, right? X plus 3, within a finite time, I can find the value of the x is equal to 2. Whereas x plus y is equal to, so you can take it as a 5. So here two unknowns are there. Hence, I cannot say you cannot solve these two unknowns, but you can solve in the not in the finite time, but you can solve it at the sometimes. So hence such a problem we can call it as a the non-deterministic polynomial. Non-deterministic polynomial. So once you solve this problem, the non-deterministic polynomial will become like the polynomial only. Hence, you can make the polynomial equal to the non-polynomial. It is possible. Okay, so please you keep this figure with you. So this is what the engineering can be. So it is a non-deterministic. Engineering is a non-deterministic polynomial. So year by year you are discovering the polynomial. You are converting the unknown into the known. But don't shift this polynomial. But you need to expand. Keep in mind, if you are expanding polynomial, you can survive, you can earn more money. If you are expanding the polynomial, instead of shifting the polynomial to the higher end, if you shifted, you may forget the remaining subject. That means you are preparing only for the examination, you are not preparing for the placement. Instead of that, so you try to go on expanding the polynomial, so that after 4 years you can make the non-deterministic one, that is engineering degree, into the deterministic one. Okay, so this is possible if you expand the polynomial. So expansion is what you should know. You are studying the second year, you should remember the first year subject. If you are studying third year, so you should recall the first year and the second year subject. When you are studying the fourth year, recall the first year, second year, and the third year, so that you can make the non-deterministic engineering course into the deterministic engineering course. This is what you can call it as a the polynomial and non-deterministic polynomial. Okay, so this is regarding P and NP class. Some of the examples are given. Next one is quantum computers. Okay, so very important. Present day, this is now taking the hot topic for especially for the computer science engineering. So we will see what is this quantum computers. Question will be there. Mandatory question will be there on the quantum computer. So please stop me whenever you stuck somewhere. Okay, if you are not understanding, please stop me, because even you go for the interview, first question present day is asking quantum computers. Okay, we'll see what is this quantum computers. Quantum computers is a problem of, it is a NP problem. You can compare this with the NP problem. Okay, so it can be solved, but not in the finite time. Okay, such a problem we can call it as a non-deterministic polynomial problem. So what is this quantum computers? How it is different from the normal computers, right? So you go back in the year 2005 and 2006, or before that in the year maybe 1996 or 1997. You were finding on the banks, so digitized the system. digitized bank or the computerized bank. Okay, so if somebody put now it is a computerized bank, people will laugh. Okay, because everything is computerized. So in the earlier days, only few banks were computerized online. Okay, nowadays all the banks are computerized. Okay, in 1995, only few banks were using. It is a polynomial. Okay, now present day what happens? All banks are. It is online only, digitized. Everything is digitized, so they cannot put the computerized banks. If the computerized bank, if somebody, some bank put computerized bank, you will laugh on them. Okay, present days, the days are not far. Okay, within 5 to 6 years, you can find some of the bank. They will include along with the bank name, and they will include. So the bank is managed by quantum computers. Okay, so quantum computers is getting nowadays the hot topic. What is this quantum computer? So quantum computer mainly by name itself, it consists of the molecules, it consists of the atom, it consists of the neutrons, it consists of the protons, it consists of the electrons. This is what you can call it as a the quantum computer. So generally the present computers, so they are far better. Even you can take the mobile, it is a far better than the computer used for the military purpose 50 years back. Okay, so it is far better. Whatever the systems they are using for the securing the military data or the some of the defense data. So our tab or mobile is more power than the systems were used 50 years back in the defense or in the army. Okay, but these computer uses, the present computer uses the only zeros and ones, right? You know, zeros and ones. So to develop any program or any hardware, the developer uses only zeros and ones. For example, you can take the problem or the program which consists of the thousand binary numbers, maybe 1 0 1 1 0 0, like that, thousand numbers. So the developer is taking lot of time to organize these numbers, because he has to take first one, then zero, then one. Okay, so he need to arrange these numbers because the computer knows only the one and the zeros. He can make use only one and zeros. Okay, so by doing this, the developer is taking a lot of time, even for the small programs. When the complex program comes, so the developer is making use of only the, for the simple also he is making use of the zeros and ones. For the complex also he is making use of the binary numbers, zeros and ones. Whereas in the case of the quantum computers, the nature of the quantum computer is a, so it is a superposition. For example, in the case of the this normal computer, what happens? Either it is a zero or one, either it is a zero or one. So in the quantum computer, its nature or the feature is a, it is a superposition. Its a nature is a superposition. Okay, so we'll see what is this superposition. Superposition is generally what happens in the case of the hydrogen atom. The electrons moves around the atom. So this is a, either in this direction or in this direction, upward or downward. Okay, so upward means you can call it as a zero, downward means you can call it as a one, or vice versa. You can take this upward as a one or the downward as a zero. Okay, so in the case of the hydrogen atom, only one electron is there. So whereas in the case of the quantum, the it is, its nature is a superposition. the meaning of the superposition is it moves upward direction, downward direction, left, right, so diagonal. Okay, so diagonal. Because of that, so we are finding this is the what you can call the superposition. So superposition, it is a quantum. The feature of the quantum is a superposition. So if the atom is in the superposition, what happens? You can find the many combinations. So in the binary computer, you can find only zeros and one, whereas because of the superposition nature, you can find the combinations of the this zeros and one. In order to get zeros and one in normal computer, you need to combine these two. You need to combine these two. Whereas in the because of this superposition nature, in the case of the quantum computer, so you can find the combination 0 1, or you can find the combination 0 1 0. So or you can find the combination 1 0 1 1. See, in order to make 1011, the developer has to take, in the case of the binary computer, he has to take 1 times 0 and 3 times 1. So because of the superposition nature, so directly he can take this 1011. Okay. So whereas here it is taking, developer is taking the four binary bits. So here is he is taking only this what you can call it as a this type of the combination, you can call it as a qubit. So bit, qubit, or you can call it as a quantum bit, or you can call it as a QUAN. Quantum bits are there. So quantum bits are there. Because of this quantum bits, the developer are finding developing a very complex problem in the finite number of times. Okay, but thing is that this is when it is non-observable. I will tell you what is this observable and non-observable. So if you are not observing this quantum, if you are not observing this quantum, it is in the case of the superposition. Once you started observing, so what is happening, it is behaving like the binary number. Only the electrons are starting moving either up or downward direction, or the electrons and protons starting either left or right side. Okay. So this is when the quantum is not observed, it is behaving like the superposition. Okay, like a superman. It can climb the 10th floor building, it can climb the 20th floor building. When it is observed, so it is behaving like a the normal, like a binary. What do you mean by observable? So observable means when this quantum is given, this quantum or the atom or the molecule is given the supply voltage. Generally what happens, it can take the computer operated with the power only. When you give the power, that is what you can call it as a observed. When you observed, this quantum is acting like a the binary only. This is what the scientists are facing this problem. When it is in the non-observed mode, okay, so without applying any electricity, so it is acting like the superposition. So superposition, the quantum bits are there. So you can find these are the quantum bits, 111. So this is one quantum bit. Okay, so this can be formed by using the binary numbers, but it is taking a lot of time to make one quantum bit. But it is already available with the this quantum or molecules. Okay, when it is observed, or you can call when this type of the computer is given the voltage, they behaving like the binary computers. Okay, so lot of research are going on in order to maintain, even though at the observation they want to keep this it in the superposition mode. So to keep this in the superposition mode, for example, our binary computer is taking 1 watt per hour. 1 watt per hour. Normal computer is taking 1 watt electricity per 1 hour, but the quantum computer is taking the 20 kilowatt per hour. Why this 20 kilowatt per hour? It consumes more power. So in order to maintain this quantum in the case of the superposition status, so it need to be operated in the 0 degree centigrade. It need to be operated in the 0 degree centigrade. So in order to operate such a type of the computers, so definitely they consumes more power. Okay, so if it is operating in the 0 degree centigrade, so the human being also tolerate this 0 degree temperature. Lot of challenges are there in the case of the quantum computer. So quantum computer is deployed. So for example, any problem, it is taking, it is a complex problem is there to solve. If it is taking 20 minutes, if it is taking 20 minutes to solve the complex problem, to execute the complex program, if it is taking 20 minutes, okay, so whatever program you are executing, maybe it is hardly taking the 30 second to 40 second. When you join the company, some of the problems are there, some of the programs, so you need to execute in the days together. Okay, 3 days, 4 days. So any problem is executing in the 3 to 20 minutes. So it can be just, I'm giving one simple example. If it is any problem is taking 20 minutes, within 1 second, so it is in the normal computer, it is in the case of the quantum computer, within 1 second you can execute the particular problem. For example, any problem in the company, any program in the company is executing in one day. In one day, after joining the company, you need to write such a complex program. So they were taking one day, whereas the quantum computers are used. It is resolved in within 20 minutes. You can imagine. So but a lot of challenges are there in the case of the quantum computer. When it is non-observed mode, it is act like a superman. When it is observed means when it is started operated by voltage, okay, or the power, it is acting like the normal human being. It is acting like a normal human being. There is a difference between the superman and the normal man. Okay, normal man can walk and superman can fly. Okay, so if he fly, he can cover a lot of the distance in the fraction of time, whereas normal man cannot do it. So this is the advantage of the quantum computer, but a lot of challenges are there. The quantum computer presently it is a non-polynomial after 4 to 5 years. So you can find some of the banks already. IBM started developing the quantum computers. They already tested on the simple problems. For example, addition of two numbers, A plus B. Okay, this IBM, Intel already they built it the quantum computers, but they are solving only the simple problems. One or two quantum computers they have, but it has to come to it is take its own time because it is a non-polynomial problem. So non-polynomial problem, I cannot say it is not solvable because you go back 15 years back, there was no mobiles. So today mobiles has come. 15 years back, the mobiles was the non-polynomial problem, non-deterministic. So somewhere after 15 years, the solution has come for this communication through the air. So this is like that. The quantum computer today, it is a non-deterministic polynomial. After 4 or 5 years, you can find some of the banks. They will put the board. This digitized quantum computers are used in order to manage the banking system. So the days are not far. So we hope everything is goes in favor of us. So shortly you can come across the quantum computer. As I told, Challenges are there. They consumes more power in order to operate it in the 0 degree centigrade. 0 degree centigrade is required in order to operate these molecules in the superposition mode. So this is regarding the quantum computer. So challenges also there. As a user, we are all familiar with this binary computer. Okay, so to cope up with the quantum computer, a lot of trainings are required for the user also. Okay, so these are the some of the challenges of the quantum computer. So quantum computer is, I'll brush up once again. Quantum computer, they uses a qubit rather than the binary bit like a 0 and 1. So this is the qubit combination, because so binary, what happens, either it is a upward or downward direction, whereas in the case of the molecules you can find this electrons are moving in the different direction. So because of that, either it can be 0 or 1, whereas here it is the combinations. So you can find it, the behavior is like a 0 1 0 0. So this is combination is not possible in the case of the binary. You want to do the combinations, the developer has to combine this zeros and one. So, but it is already combinations is available in the quantum number computer. Such a combination we can call it as a quantum bit or qubit. It is called as a qubit. Qubit means superposition. They can move in any of the direction. So if you are using these combinations, developing of the complex problem becomes very simple. This is regarding the quantum computer. So please refer the question paper. Many times a question has been asked. If you read the book now on the quantum computer, anyhow, I am going to share the notes, fifth model notes. You please go through this notes so that you can easily understand, and the same thing you can implement it in the exam also. So the next one is a post correspondence problem. So this is the problem, is undecidable problem that was introduced by Emil Leon Post. It is a scientist name, Emil Leon Post. It is a undecidable problem. So in this case, what happens? Two strings are there. One string is in the numerator, and the other string is in the denominator. Okay, so you need to make this numerator string should be equal to the denominator string. Denominator string. For example, if the question is asked, explain with the example, means you can take your own example and explain. It is very easy. Okay, so I will show you. If the question is asked, explain post correspondence problem with any example, so the days is yours. If he has given the sum of the qubits or sum of the binary bits, you need to organize in order to produce the numerator as well as denominator equal, but it is not so complex. It is not a decidable one, I can say. It is undecidable one, but somewhere you can solve it in the beyond the infinite time. I cannot say it cannot be solved, the post corresponding problem. It can be solved, but we cannot solve in the finite time. That's what such a problem we can call it as a the undecidable problem. How it works? This post correspondence problem. For example, you can take the two numbers. One number is you can take two sets are given. One set is you can call it as A and other set is B. For example, you can take the first one. First one is it is a one. First one is one. A is one, whereas B is triple one. B is it is a one one one. Second case, so A is it is a 10 triple one, 10 triple one, 10 triple one. Okay, and the B is, it is a 10. B, you can take it as a 10. B is a 10. In the third case, A is, so it is a 10. A is 10. A is 10, and B is, it is a 0. B is 0. So how do you make the denominator string? You can call it as a X as a denominator string, Y as a the sorry, X is a numerator string and Y is the denominator string. How do you make X string and Y string is equal? So in order to make X string and Y string, so I should start. So I cannot start with this. I cannot start with this because it is started with the 0 and it is started with the 10. Okay. I cannot start with this string. I can start this. So I can start this, but this is only single one and this is the three ones. See, you can observe here, this is 10 and this is also begins with the 10. So you can start the x with the 2. So x with the 2, even y also with the 2. So x is with the 2. So x is what? So first string numerator is made up of the a, and the denominator is made up of the b. But numbers are same. If you are taking a as a 2, x as a 2, so x is a. X is a. So x as a 2, it is a 10 1 1 1. 10 1 1 1. Whereas denominator is, it should be 2 only. So this is the 2. Why is it is a 2? 2 means it is a 10. Okay. So till they are not equal. They are not equal. Okay. So it is a 10 1 1 1 numerator, whereas denominator is, it is a 10. In order to make equal, you should choose the number in such a way that you should make the denominator is equal to the numerator. This is possible. So for that, I can take 1. So 1, if you are taking in the case of the x, it is a 1 only. For the next step, I'll take. So first step is, it is a 10 1 1 1. Second step, so a I will take it as a 1. A I will take it as a, this is 2. This is 2. Okay. Now this is 1. This is also 2. You need to take 2 only. 1 0. This is a 2 from the B. Now from the B, 1 is, it is a 1 1 1. 1 is 1 1 1. Okay. Next I have taken, this is a 2. This is 1 1 1. Till, so we are finding irregularity between the denominator and the numerator. So denominator is 10111, but in the numerator it is a 10111. Okay, so you should make both these strings x and y equal by making use of the a and b. Okay, A and B, if you're taking the second one for the A, B should be second one. You cannot take A as a 2 and B as a 1. Okay, next, in order to make equal, this is a 1, this is extra 1 is there. So you can come, which one is 1? So this is 1. Okay, it start with the 1. If you are taking this second one, you need to take a also, this for the string x you need to take 10111. Okay, again this x will becomes lengthier than the y. This is x and this is y. Okay, next option is it is a 1 only. I can take 1. 1 means for the x string it is a only 1. For the x string it is a 1. Whereas for the y, again it is a 1 1 1. For the y it is a 1 1 1. Now you can make out. Now the y is lengthier or the larger than the x. Okay. So what you will do? So which one is works? Now this is a lengthier. This one is b strings lengthier than the a strings. Okay. Next, which one makes equal? For example, if I'm taking 3, if I'm taking 3, so in the case of the y, it is a 0. In the case of y, it is a 0. Whereas in the case of the a, or it is in the case of the x, it is a 1 0. So now I'll write this as a 10. See, now I made the numerator is equal to the denominator, or the string x is equal to the string y. So this type of the solution we can call it as a the post correspondence problem. For example, you can take the string, different strings. One as a, this is B, A B. First one is you can take 10. First one as a 10, B as a 101, B as a 101. Second one you can take 011. Second string as a 011. These are the input given for the problem. So corresponding problem. Okay, input is given 11. Okay. Third one you can take it as a 101, 101, 101, and this as a 011. Okay, if you are starting the if you are starting with the 1 for the string x numerator, y is a denominator. If you are starting with the 1, 1 is a 10, it is a 10 in the case of the x, whereas in the case of the y, it is a 101. So 1 is larger, y is larger than the x. Denominator is larger than the x. So in order to make equal, so I can take the 3. I can take the 3. 3 is in the a case, or in the x case, it is a 101. 101. Whereas 3 in the case of the b is in the denominator, it is 0, 1, 1. Matching is there. See, you can find the matching with these numbers 2, 1, 1, 3. Matching is there, and their length should be equal. Length should be equal. The first one is 1, 1, 0, 0, 1, 1. This is what you can call it as a the post correspondence problem. Solution for the post correspondence problem. All the third bit should be same, fourth bit should be same in the denominator as well as in the numerator, and their length should be same. If you are concluding the solution of the post correspondence problem, all the bits should be equal and their length should be equal. X numerator length should be equal to, for example, if it is taking the 9 bits, so here also you should have the 9 bits, not less, not more. And each bit should be equal. First bit is C, both the side it is a 1, so here also 1. Second bit is 0, second bit is 0. Last bit is 0, the last bit is 0. Last but one is bit is 1, so here also last but bit is 1. I'm taking care now. If you are taking 3, so 3 is a 101. So 3 is a 101. So I have taken 101. So here 3 is a 011. So again, the denominator is longer than the numerator. So in order to do this, I can take again the 3. So if you're taking 3 for the string x, it is again 101, 101. 3 for the denominator, it is a 011. See, every time you take any combinations, but it should be same. If you are taking one for the a, one for the numerator, for the denominator also you have to take one only. So if you are taking any numbers, this 1, 2, 3, so we are never finding bits are same, but as far as the length, the denominator is it is longer than the numerator. Okay, so in such a case, if the problem is given like this, so for this problem, there is no solution for the post correspondence problem. So you will never have the solution for such a problems. So in the case of the PCP, post correspondence problems, we never conclude. This is you can conclude in the particular time, maybe more time. Such a problem we can call it as a non-deterministic problem. We do not have the solution. Somewhere we have the solution, but in the finite time we are unable to find. So for this problem, in the case of the post correspondence problem, the both the x and y length is equal, even the bits are same, whereas I am maintaining the bits are equal. Okay, but it is taking me to the infinity in order to make x and y equal. Hence, for such a problem, in the case of the post correspondence problem, we do not have the solution for such a problem. We have the solution for only this type of the problem, but we do not have the solution for this problem in the case of the post current correspondence problem. So almost I covered all the bits. Maybe you take the fourth model and the fifth model. Most of the time, only 10 questions are repeated. So 40 marks. If you read this 10 questions, you can read it 2 to 3 hours. So 40 marks is in your pocket. Passing is not a problem. So your target is not only passing, so because it is a one of the technical subject, if you know, if you scored good marks in the this ATC, definitely the HR will appreciate you. So he may offer with the high package, because this is the technique subject. So a lot of techniques are involved. So the level is very high. The analyzing problems are there. The evaluating problems are there. The especially first and second model, its level is creative. Design are there. Most of the problem it begins with the design. Hence, a lot of creativity is required. If I solve 10 problem, the 11th problem somebody might have solved in the other college, so it may come in the examination. Okay, so instead of investing, wasting, because in the examination, time is very precious. If you invested a lot of time on the this design, okay, so you may not, even though you know the fourth and fifth questions, you may not attempt these questions because shortage of the time. Okay, so my request is, if you know this fourth model question perfectly and fifth model question perfectly, you can take. There is a no restriction. Don't think if I attempt the fourth question first and the first question last, examiner, you may lose the impression of the examiner. It is not like that. So if you know the some of the questions thoroughly, you can present it. Then slowly impression you can uh, leave the very good impression on the examiner. If you are presenting very neatly the fourth model question or fifth model questions, so you can expect very good marks on this impression. Once you leave the good impression on the examiner. So if you are expecting 3 marks, he may give the 4 marks. Okay. The last one is, it is a universal Turing machine. So as I told, it is like a digital computer. Okay, digital computer, universal Turing machine. So it is almost equal to the digital Turing machine. But in the case of the, it is a digital computer. Okay, so digital computer handles many problems, right? So it handles almost, see, it handles A plus B. It handles A into B. It handles A division by B. But in the case of the Turing machine, what happens if you design Turing machine for the A plus B, it may not work for the A into B. It may not work for the A divisible by B. Whereas in the case of the universal Turing machine, it is a little bit the complex Turing machine. So in the this universal Turing machine, it handles maybe the same machine handles the A plus B also. It handles the Turing machine handles same Turing machine handles A into B. So same Turing machine handles A division by B. Same Turing machine handles A minus B. So such a Turing machines, we can call it as a universal Turing machine. So the last Turing machine is, it is a multi-dimensional Turing machine. So in the case of the multi-dimensional Turing machine, what happens? So generally the Turing machine reads, it reads the input symbols by moving left as well as right. Whereas in the case of the multi-dimensional, multi-dimensional tapes has been combined. Multi-tapes has been combined in the case of the multi-dimensional Turing machine. So this is what the input tape is there. They are organized in the multi-dimensional. Okay. So for example, if the Turing machine or the finite controller is reading, it is located at this point. A normal Turing machine, what happens? Either it can move, if it is in this case, either it can move to the left or it can move to the right. Whereas in the case of the multi-dimensional Turing machines, so not only it is moving right as well as the left, it can move the up as well as the down also. So such a type of the in order to read the input strings, so in the normal standard Turing machine, it was moving only left and right. Whereas here, not only left and right, it can move even upward direction as well as downward directions. Okay, directions are more. So along with the this left and right, so we have the in the transition functions, we have the u and down, u and down. So this is the, so in the output side we have the Q, we have the tape symbol. Standard Turing machine only left and right over there, whereas in the multi-dimensional it can move in order to read the input string, to convert the input string into the tape symbols. So it is moving left, right, upward direction as well as the downward direction. So such a type of the Turing machines, you can call it as a the multi-dimensional Turing machines. Is there the multi-dimensional Turing machines? Somewhere I included multi-head Turing machine is there, non-deterministic Turing machine. Okay. With this, almost I covered the questions which are appear in the fourth model and the fifth model. Okay. Any